Well, what did the graphs of the exponential function look like? They all look alike. And if I take a look, here's where b, or the base, is greater than 1. Base greater than 1 looks like this guy. And what he does is he runs along the x-axis. And by the way, what he does, the x-axis, you'll find out in college algebra, this is where y equals 0. And this is going to be an important piece of information for us. This is called a horizontal asymptote. A horizontal asymptote. A-S-Y-M-P-T-O-T-E. Horizontal asymptote. All it is a floor for the graph. Could be a floor or a ceiling. In this case, it's a floor. It's kind of like if something is coming down and it's going to ride along the floor. It doesn't go below the floor, but just kind of rides along the floor. That's what that graph does. It just rides along the axis. Now, if b is between 0 and 1, in other words, this is going to be a fraction less than 1, but greater than 0. 1/2, 1/3, 1/4, between 0 and 1. What it does is it flips it around the x-axis, or y-axis, excuse me. And now what you have is the graph is going to go the other direction and ride again along the x-axis. This is y equals 0 is a horizontal asymptote. And all exponential functions look alike. They all act alike. You see one, you see them all, just where they are. As you find out in college algebra, it's just where they're located on the graph paper. In intermediate algebra, what you find is they just all look alike. Location is not as much of an issue. Now, other thing I want you to notice is this. The domain is what? All real numbers. So minus infinity to infinity. I can put in any x value I choose. The domain is all real numbers. So therefore, when I go to graph it and I want to set up a t-bar chart, if I want to graph y equals 3 to the x, I put in -2, -1, 0, 1, and 2. I go on either side of 0. Because it's all real numbers. If I had a restriction, then I would include the restriction, but I don't have any restriction in the domain. So this would be 3 to the -2, which is 1 over 3 squared, or 1/9, very close to the x-axis. This is 3 to the -1, which is 1 over 3, or 1/3. It's getting bigger. This is 3 to the 0, which is 1. This is 3 to the 1, which is 3. This is 3 to the 2, which is 9. Now we have to remember what this guy looks like. At -2, very close to the x-axis. At -1, about 1/3. At 1, 0. Or at 0, 1, excuse me. At 1, 3. And at 2, 9. Now connect the dots. Now, what I know is, as x gets bigger, y gets bigger, so he's going to continue on out. And as x goes more negative, he's going to ride along, but not cross the x-axis. because we have to remember this. Y equals 0 is a horizontal asymptote. So that means he's going to ride along that axis. He will never cross it. Not in this basic form, unless we do something that makes him cross it. Unless we change the horizontal asymptote. But no, he will never cross it.